Heidi-ho, let's get going. Example 3. A ramp is 120 feet long and rises vertically 15 feet. Find the angle of elevation of the ramp. Okay, so again, I did my best, you guys. So we have the ground, then we have this ramp that heads up, and then we have the top of the ramp, which is now the new ground. Okay, so I tried to demonstrate that the best I can. These dashed lines are what is going on behind the scenes. So always a ramp will rise a certain amount and go horizontally a certain amount. So the horizontal distance of the ramp can be represented right here. The vertical distance of the ramp can be represented right here. And when the vertical and horizontal distance meet, guess what? They form a right angle, which means we have a right triangle. And we can now use sine, cosine, or tangent. Don't forget the nifty acronym SOHCAHTOA. Okay, so let's start labeling our picture and let's get started. So a ramp is 120 feet long. Okay, so the actual ramp itself is 120 feet, not the horizontal distance, the ramp itself. Okay, so the ramp is 120 feet long. Feet is probably going to be our units, just saying. So 120 feet is the length of the ramp. Okay, and it rises vertically 15 feet. So that is referring to our vertical distance, which we know to be 15 feet. So our vertical distance is 15 feet. Let's see, didn't leave a whole lot of space. So our vertical distance is 15 feet. I guess I'll write it here because I'm out of space. Okay, find the angle of elevation of the ramp. Okay, so we're dealing with an angle of elevation again, so that's good to know. So angle of elevation. Okay, and from here we want to know what that angle of elevation is. So this time we're actually solving for an angle measure, not a side length. So this time we're not going to be cross multiplying. Remember, whenever you're solving for an angle on a right triangle other than the right angle, okay, whenever you're solving for an angle on a right triangle, you're going to be using an inverse trig function at some point, so don't forget. Okay, so I need to figure out what part of my triangle is the angle of elevation. Well, the angle of elevation is created by a horizontal line and the line above it. Alright, so the horizontal line is right here, and when the ramp starts to head upwards, the horizontal line will rise up. So the angle of elevation is going to be this angle right here. This is the angle I don't know, and I'm going to call that x, which I didn't leave enough room in my picture to write that. So if you left enough room, it would be better for you to write x right there. So we're solving for the angle right there, x. Okay, well, let's get started, you guys. So first thing, let's label the parts that we were either given or trying to solve for, which this time we were given the two sides of the right triangle. Guys, so this side, the vertical distance of 15 feet, well, that is the side directly across from the angle of elevation we're solving for. So which side of the right triangle is the 15 feet? Absolutely, that would be the opposite side. So I have an opposite. And then this side, the side that is directly across from the right angle, well, that is called the hypotenuse. So I have an opposite and a hypotenuse. So which trig function am I using? That would be sine. So I'm using sine. So the sine of the angle, well, I currently don't know the angle, so I'm going to call it x. It's our angle of elevation. Okay, that will be the opposite over a hypotenuse. Okay, so the opposite side, the side directly across from the angle, well, that's 15 feet. Okay, and then the hypotenuse is going to be the ramp length, which is 120. So 120. All right, now technically, you guys, we can reduce this down. Now, honestly, it really doesn't matter if we reduce it down because the calculator is going to do all the work for us. So instead of wasting time reducing this down, you can reduce it down. I mean, if you choose to reduce down your fraction, you'll end up seeing that you're going to get the same answer from me. So I know, I love to reduce things down. I know. Okay, but you also know that mathematicians are efficient And if we don't have to reduce down something, then we won't. Okay, so usually we reduce down answers to either help us solve or to give our answer in its most simplified form, so we actually kind of have a better idea of what you're dealing with. Okay, but anyway, so I'm not going to reduce that down. But again, if you'd like to, you'll see that we get the same thing. So I'll leave it up to you. Okay, let's solve this thing for x. Currently, my x is trapped inside of sine. Okay, so I need to get x out of sine. Okay, I need something to cancel out the sine so my x will be free. So what can I do on both sides of my equation to get rid of the sine? Well, what is the inverse of sine? Yes, that is correct. It would be inverse sine. So I'm going to take the inverse sine of both sides of my equation. Okay, so don't forget, anytime that you're solving for an angle in your right triangle, you will be using inverse trig. An inverse trig function will appear, so just keep that in mind. So I'm going to take this inverse sine of both sides of my equation. I'm just going to rewrite this part inside of here and this part inside of here. So this part goes in here. So sine of x. All right, and then this part goes in here. So it would be 15 over 120. Okay, which guess what, you guys? The inverse sine and the sine cancel each other out, which means I'm left with x. So x, I'm going to bring this up here. X is going to end up equaling the inverse sine of 15 over 120. All right, and from here, we just need to solve. And we're solving, okay, I was actually wrong. Since we're solving for an angle, our units won't be in feet, they'll be in degrees. So, I guessed wrong. So, see, it's always good to check yourself at the end. So, my answer will be in degrees since we're talking about an angle measure. Okay, let's type this in our nifty calculator. Okay, so I'm going to type inverse sine. Remember how you get to the inverse function? It's sitting right above the sine button, which means I need to hit second. So second sine. Then I'm going to type 15 divided by 120. And look at that. The angle of elevation, why don't we just round to the nearest degree? So that 0.1 will not bump up my 7. So this will be 7 degrees. So again, it is a ramp. You don't really, most of the time you don't want ramps to be too steep or else it's going to be really hard to get up and down the ramp. So the angle of elevation, or the angle created by the ground and the ramp, will be 7 degrees. And again, you can also type this on Desmos.com. So real quickly, I'll show you that. So I'm just going to type it in. So I'm going to type sine. I'm going to raise it to the -1 power, even though that's not really what I'm doing. But I'm going to write the inverse symbol. And then I'm going to type 15 over 120. And look at that. We get the same thing, 7 degrees. And don't forget, I could have also done the same thing by clicking on my function button and going to the inverse sine button right there. So there you go, 15 over 120. And look at that, the same thing. Well, that's it, you guys. Example 4 and 5 will now be dealing with angles of depression, so get excited.